For the past 2 years, the AI conversation has been dominated by a handful of closed proprietary systems. OpenAI, Google, Anthropic. Big companies with massive computing budgets and lockdown models. You use their product, you follow their rules, you pay their prices. But something is shifting. Open source AI models, models where the weights are public, where anyone can download and run them, have been catching up at an astonishing pace. And in some cases, they're now competitive with the best proprietary models on the market. This matters enormously, not just for researchers and developers, but for everyone who cares about who controls AI, what it costs, and what's possible. Let me break down everything you need to know. Before we get into the details, let's clarify what we're actually talking about, because open source AI is a somewhat loaded and contested term. In traditional software, open source means the code is publicly available. You can read it, modify it, distribute it. Simple. With AI, it's more complicated because a model has multiple components: the training code, the training data, and the model weights. The weights are basically the learned knowledge baked into the model after training, the billions of numerical parameters that encode everything the model knows and can do. When companies say they're releasing an open model, what they typically mean is they're releasing the weights. You can download and run the model, you can fine-tune it on your own data, you can modify it and build products on top of it. But many of these open models still don't release their training data or full training code, which means you can't truly reproduce or verify how they were built. This is why there's ongoing debate about whether to call them open source or something more precise like open weights. For this video, when I say open source AI, I'm talking about open weights models, models where you can download and run the actual neural network yourself. Let's run through the major players in the open weights space, because the landscape has gotten crowded and impressive very quickly. Meta's Llama family is the most prominent open weights model series. Llama 2 launched in mid-2023 and was a significant moment. Meta, one of the largest AI research organizations in the world, releasing competitive models freely. Llama 3, released in 2024, pushed the bar further, with the 70 billion parameter version competing with GPT 3.5 and even approaching GPT 4 in many benchmarks. Meta has continued iterating aggressively. Mistral AI, a French startup, has been punching above its weight class with incredibly efficient open models. Their models are small and fast, but surprisingly capable. Mixtral, their mixture of experts model, performs like models twice its size and can run on consumer hardware. Google DeepMind released the Gemma series, smaller open models designed for research and on-device use. While not quite at the frontier, Gemma models are well optimized for running locally. Microsoft has released the Phi series, small language models, SLMs, designed to be highly capable despite their compact size. Phi 3 surprised a lot of people with its performance on reasoning benchmarks. Alibaba's Qwen series, Erl1 AI's Yi models, and a range of Chinese AI labs have also released competitive open models, contributing to a genuinely global ecosystem. And then there's the research community layer. Hugging Face hosts thousands of community fine-tunes, domain-specific models, and experimental variants built on top of these base models. This is the question everyone wants answered. Are open models actually competitive with GPT-4, Claude 3, or Gemini? The honest answer is, it depends on what you're measuring. On many standard benchmarks, reading comprehension, reasoning tasks, coding challenges, the gap has closed dramatically. Meta's Llama 370B and Mistral's larger models perform comparably to GPT 3.5 and give GPT-4 a real run in certain categories. For specific domains, open models that have been fine-tuned on specialized data can actually outperform generalist closed models. A medical model fine-tuned on clinical literature may outperform vanilla GPT-4 on medical tasks. A coding model fine-tuned on millions of open-source repositories may be better at certain coding tasks than a general-purpose closed model. Where closed models still have advantages, at the absolute frontier, the very best reasoning, the most nuanced instruction following, the broadest general knowledge, GPT-4o, Claude 3 Opus, and Gemini Ultra still lead. The top of the closed model tier represents something like 2 to 12 months ahead of the best open models, depending on who you ask. But here's the key insight. The gap is closing, and the pace of open model development is accelerating. The open source community benefits from the same research that the closed labs publish, from community innovations, and from sheer numbers. Thousands of researchers worldwide working on improvements versus a few hundred at any single closed lab. The technical details are interesting, but the reason this matters goes beyond benchmarks. Privacy and data sovereignty. When you run a model locally on your own hardware, your data never leaves your machine. For healthcare, legal, financial, and government applications, where data privacy is paramount, this is crucial. You're not sending sensitive patient records or confidential legal documents to an external server. Everything stays on premises. Cost. API calls to proprietary models like GPT-4 add up fast at scale. If you're processing millions of documents or running a high-volume application, the economics can get brutal. Open models run on your own hardware, so once you've paid for the compute, the marginal cost of inference is essentially zero. Customization. With open weights, you can fine-tune the model on your own data, reshape its behavior, and create something tailored to your specific use case. This level of customization is simply not available with locked models or comes with severe limitations. Independence and vendor lock-in. When your entire business depends on OpenAI's API, you're at their mercy for pricing changes, policy updates, or service disruptions. Open models give you independence. You can run them yourself or work with any of dozens of providers who host them. Geopolitical and regulatory resilience. As AI regulation evolves, having models that you can run without depending on any single company's compliance decisions gives individuals, businesses, and governments more flexibility. Let me get practical for a second. Can you actually run these models yourself? And what does that take? Yes, you can, and it's gotten remarkably accessible. On a modern laptop or desktop, smaller models in the 7 billion to 13 billion parameter range can run on a standard MacBook with Apple Silicon or a PC with a decent GPU. Tools like Llama for Mac, Windows, Linux, and LM Studio have made this almost plug and play. Download the tool, download the model, start chatting. This is completely free and runs entirely offline. For larger models, the 70B parameter models need serious hardware, typically 40 gigabytes or more of GPU memory. That means either multiple high-end consumer GPUs, a professional GPU like an A100, or running the model in the cloud. In the cloud, services like Together AI, Replicate, Fireworks AI, and others host open models and let you access them via API, often at a fraction of the cost of OpenAI or Anthropic. You get the flexibility of open models without needing to manage your own hardware. The tooling ecosystem has matured dramatically. A year ago, running local open models was a project for technical enthusiasts. Today, it's approachable for anyone who can follow a setup guide. This section exists because I believe in being intellectually honest, not just hype maximizing. There's a genuine debate about whether open sourcing powerful AI models is responsible. The argument against, if a model can be used for harm, generating disinformation at scale, assisting with creating dangerous materials, enabling sophisticated cyber attacks, then releasing it freely means you can't control how it's used. You can't retroactively pull the weights back. Meta has defended their approach by arguing that the benefits of democratizing AI access outweigh the risks, and that security through obscurity, keeping models closed, doesn't actually stop sophisticated bad actors who have the resources to build their own. They also point to safety fine-tuning and usage policies. The counter-argument notes that the open models released by Meta and others are already capability limited compared to what nation-states or well-funded groups could build privately, so the marginal risk to bad actors is lower than critics suggest. This debate isn't settled. As models get more capable, the tension between openness and safety will only intensify. It's one of the defining questions of this period in AI development. Open source AI isn't just a technical footnote. It's a genuine challenge to the closed, centralized model that big tech has been building. It represents privacy, independence, customization, and democratized access. It's also a live experiment in whether you can have capable AI and open access at the same time. Watch this space. The open weights ecosystem is moving fast, and the models releasing 6 months from now will be significantly more capable than what exists today. If this was useful, like and subscribe. I cover AI and tech developments that actually shape the future, and I try to do it without the hype. See you next time.